Myself, Adil Hussain Sheikh, Assistant Professor, Automobile Department, LJIET, and welcome to the lecture series of Advanced Combustion Technology of ICN. Today, we are going to discuss about, in particular session, about direct injection natural gas engines. As we know about that, today in particular world, natural gas is the most important fuel of particular regarding IC engines. So, in this particular chapter, we are going to discuss about natural gas engine introductions as well as how can we build an engine with the help of natural gas, as well as we are going to discuss about fuel injection strategy using in natural gas engines, as well as we are also discuss about ignitions and combustion phenomena of natural gas engines in this particular chapters. And most important things, why we are using natural gas engines nowadays, in particular IC engines, because of their emission control. So in this particular chapter, we are also discuss about their emission control regarding particular IC engines. So let us start discussion about it. So in particular introduction session, we are going to discuss about how can we categorize natural gas engines with different types of parameters. So basically there are three types of parameters. First one is the most important parameter, it's mixture preparation, right? Basically there are two types of mixture preparation. First one is the pre-mix preparation and second one is the non-pre-mix preparation. So how can we differentiate this mixture preparation? So I can give you one best example. Basically there are two types of injection we see. First one is suction suction stroke injection, and second thing is compression stroke injection, right? And nowadays we are using gasoline direct injection technology. How GDI works, as I have already discussed in previous sessions, and how suction stroke injection works and compression stroke injection was also I have discussed in previous lectures. But I can give you brief explanation regarding suction stroke injection. In suction stroke injection, our air and fuel directly injected into combustion chamber while suction stroke is happening, and in compression stroke injection air and fuel mixture injected in the particularly compression stroke while compression stroke performing in particular combustion chamber. At that time injectors directly inject fuel particularly combustion chamber. So with the help of this phenomenon we can directly get these types of mixture in particular combustion chamber. So mixture preparation is the most important and play vital role in the natural gas engines. Now second thing is that we are also using another parameters like ignition systems. Basically, there are two types of ignition system as we know about that. First one is the spark ignition systems, and second thing is the diesel pilot ignition systems. How spark ignition works and how diesel pilot works, as we know that in the spark ignition system we are using spark plug systems, and with the help of this spark plug we can get a basic spark in particular combustion chamber, and with the help of this spark we can get ignition with proper full propagation. Similarly, in diesel pilot system, happening same phenomena in particularly diesel engines. And most important parameters regarding natural gas engine is the dominant cycles, right? There are so many cycles in particularly thermodynamic systems. So basically, we are using Otto cycles and diesel cycles in this particular natural gas engines. As we know that Otto cycle works on the basically petrol and diesel cycle works on particularly TI engines, right? Or we know that we are using also dual engines in particular system. So these are the basic category of the parameters at which we can categorize natural gas engines. First one is the mixture preparation, most important thing. Second thing is the ignition systems. How can we ignite particularly this air fuel mixtures regarding natural gas engines, and third one is the dominant engine cycles. Basically only two cycles we are using in this particular systems, auto cycles and diesel cycles. Okay, now let us move on further. These are the basic three uh, category of the natural gas engine. So first one is the pre-mixed charge spark ignition natural gas only. Second thing is the Pre-mixed are diesel pilot ignition, or we can say that is a natural gas diesel dual fuel systems. Or third one is the high pressure direct injection of natural gas diesel pilot, or we can say there is a diesel fuel system. So basically these are the three categorized engines of the natural gas category. First one is the spark ignited engines, second thing is the dual fuel systems, and third one is the high pressure direct injection system. In particular, third figure, I can say that high pressure direct injection system is the most efficient technology used in this particular natural gas system, because pre-mixed charge SI engines and pre-mixed charge CI engines is also well established and useful system. But high pressure direct injection technology is the well established and most efficient technology comparatively spark ignition and diesel pilot ignition system, because in high pressure direct injection system we can get high efficiency of the pressure, as well as we can also get the better volumetric efficiency, and we can also get a better emission control with respect to injection strategy. See, the most important task, how can we decide our ignition and injection system? As per concern of the particular combustion side, we can directly select EDI system with this particular natural gas engine, so we can get better efficiency as well as we can get better results. So this is the introduction phenomena of the particular introduction of the natural gas engines. So let us discuss about build up an engines. How can we build up an engines regarding natural gas fuel? Okay. See, whenever we are using natural gas, in particularly SI engines, at that time we have to look for some basic parameters like temperature of the engines, as well as the combustion phenomena of the engines, as well as we also look for the particular efficiency of the engines, right? Because we are directly injected gas in combustion chambers, and when we are injected gas in particular combustion chambers, at that time we have to know about that temperature of the engine, pressure of the engines, and particularly cooling and lubrication system of the engine, right? So, how can we define these parameters and how can we build up an engine with the help of this criteria? So, basically, there are four types of engines going to be designed with the help of this system. So first one is stoichiometric auto cycle engines. Second thing is the lean one auto cycle engines. Third one is the dual fuel mixed cycles, or we can say that the combination of auto and diesel engine cycles. And third one is the diesel cycle natural gas engine. So basically, these are the four engines as we can build up with the help of natural gas engines. In stoichiometric auto cycle engines, let us discuss stoichiometric auto cycle engines. In stoichiometric auto cycle engines, as we know that we have to take one reference regarding particular engines. So in stoichiometric auto cycle engines, we are using stoichiometric ratio. And we know that about stoichiometric ratio is 14.5 jam 1. So we are using stoichiometric ratio in this particular engines, and with the help of this reference values, we can generate another engines regarding natural gas sites. Okay. See, stoichiometric auto cycle engines is the reference engine. Okay. As we know that stoichiometric ratio is very difficult to obtain while running conditions. Okay, right? But with reference, we can take stoichiometric auto cycle engines. So with the help of this reference, we can design lean one auto cycle as well as dual fuel mix auto cycles, as well as diesel cycle natural gas engines. So with the help of this stoichiometric auto cycle engines, we can generate another three engines regarding natural gas fuel. In lean one auto cycle engines, we are using lean mixtures, right? As we know that what is the as we know that about lean mixtures, and how can we generate lean mixture in particularly systems. We all know about that in lean mixture we are using more air compared to fuel. In dual fuel mix cycles means we are using both phenomena of auto cycles and phenomena of diesel cycles, right? Which are the phenomena of auto cycles? Basically, we are using constant volume and constant pressure cycles in particularly dual mix cycles engines. And finally, in diesel cycle natural gas engines, we are using particular some natural gas engines directly designed to the for diesel engines. Okay, like we are using constant pressure phenomenon with respect to these cycles, and with the help of these cycles we can generate natural gas engine. So this is it from this particular lectures, and in this in very next lecture, we are going to discuss about detailing regarding lean burn auto cycle engines as well as dual fuel mixed cycle engines as well as natural gas engines. And we are also going to discuss about injection, emission and ignition strategy of particularly natural gas engines cycles. Till date, stay home and thank you.